All right, so we are going to be talking, Ian. So today we're going to be talking about length mainly in area. Okay, let's move on. Okay, so let's talk about the metric system a little bit. So you guys understand obviously a fair amount in what you said in your answers to our question of the day. So the metric system is used throughout the world, not everywhere, but in the vast majority of countries, as a system of measurement. And the metric system offers some advantages over what we use as our typical customary system. What advantage does the metric system offer? Michael?
Well, you can get like really small measurements, like decimal measurements. Those are smallest in like the customary.
Yeah, it goes larger and smaller than customary units on each end. What else, Zach?
It's measured in tens, it's not measured in whacked out 12s.
Yes, it's units are based in the powers of 10, not whacked out numbers such as 12 or 16 or 8, as Zach would say. And that's true. And that makes what easier? Sophia? Yeah, converting from one measurement to another. You know, if you're going to convert your height in feet to inches, what do you have to do? No.
Multiply by 12.
Multiply by 12. If you're converting from inches to feet, what do you have to do, Lucas? Divide by 12. If you're converting from ounces to cups, what do you have to do?
Divide by 18.
No. Sophia?
Oh, no,
16. So these random conversion factors that, and maybe in home careers this year you might have to memorize some of them. But there's all these random conversions that don't really make much sense. In the metric system, because everything is base 10 and our counting system is base 10, then that makes things easier. And we can convert from a smaller to a larger unit or vice versa simply by moving decimals. Okay? So the metric system uses base units depending on what you're measuring. For example, the base unit of length in the decimals in the metric system is what? The unit of length in the metric system. Yeah?
Meter.
Meters. How about mass?
Grams.
Grams. Volume. Okay. Liters. Okay. So those base units are then modified to form the other units by adding prefixes. And the prefixes I'm sure you're familiar with. Milli, centi, kilo. We don't use deci very much, deca or hecto. They are there. All the steps are there, and it goes beyond this in each end. But for our purposes, we're going to really mostly use three prefixes. Kilo, centi, and milli. Okay? And so we see that kilo means what in terms of our metric system, Sophia? What? 1,000. A kilo anything is 1,000 of the base units. Centi means what, Daniel?
0.01.
Yeah, or what do we call that?
100.
100th. Milli? Vanilli? Lucas?
It's 1,000.
1,000. Those are our most commonly used measurements. And to convert from one to the other, it's very, very simple. If you could remember this chart, if I want to go from centimeters to the base unit, I have to move the decimal. Which direction? To the left. How many spots? 1, 2. To go from milli to centi, what do I do?
Go to the left.
Left 1. Centi to milli?
Go to the right one.
Right 1. Kilo to base unit?
Right.
Right 3. Kilo to centi?
Right 6.
No.
Right
5. Kilo to milli?
Right 6.
Right 6. So by understanding that pattern, we could simply move decimals left or right, adding zeros as necessary, to convert from one unit to another. Michael?
I'm kind of confused on that because when you're making, like when you're like multiplying like a decimal by 10, you move decimal like right.
Yes, that's true. But when you're going from centa, you're going from a smaller unit to a larger unit. So it's like you're dividing. If you have 100 centimeters, and you want to know how many meters that is, what would you do? You could divide by 100, or you can multiply by 0.01, and that's moving the decimal to the left. We'll do some examples that'll be clear. So if I look in the international system, the SI system, sometimes it's called, meter is the base unit of length. How many meters are there in a kilometer? Sasha? 1,000. Or 1,000. How many centimeters in a meter? Lucas?
There is 1,000. I mean, 100.
There's 100 centimeters in a meter. And how many millimeters in a meter? Mahmood?
1,000.
1,000. And we'll do some practice conversion. But it's similar sort of thing. The base unit of mass is grams. How many grams in a kilogram? Grams in a kilogram. Madison?
1,000.
1,000. How many milligrams in a gram? Milligrams in a gram. Mahmood?
100.
Nope. Milli means, Maria? What? Nope.
Oh, 1,000.
1,000. Milli means 1,000. Don't confuse it with a million. How many milligrams in a kilogram? Greg?
1,000,000.
A million. How did you come up with that? 1,000 times 1,000. 1 million milligrams in a kilogram. All right, so let's look at some conversions. So if we want to convert milligrams into grams, now vision in your mind the chart I just showed you, milligrams to grams. Let's go back to it for a second. Milligrams to the base unit, grams. Which way am I going to move my decimal?
Left.
How many spots?
3.
1, 2, 3. So here's my decimal, move it to the left. 1, 2, 3. What do I get? 1. One kilogram. Tell me how you arrive at it first. So to go from kilograms to grams. Which way are we going, Caitlin? How many? 3. Giving us what? 3 to the right from this goes to what? 1,000. Centimeters to millimeters. Think about that chart. Centimeters to millimeters. Which way are we going? Sophia?
The decimal 1 place to millimeter, which is 1,600.
Yes, decimal goes 1 to the right from centimeters to millimeters, giving us 1,600. Kilometers to meters. Which direction are we going and how many places? Michael?
You're going left? No. Yeah. Right.
Where's kilometers on that chart?
Right here.
Far left.
So you're going right.
We're going to the right, how many spots?
4.
3 kilometers, and there's 2 more at the base. So if we move the decimal place over 3 here, what do we get?
14,000.
14,000. Grams to kilograms. Grams the base unit, kilograms all the way over to the left. You've seen the same hands. How about some people that are not 100% sure yet? Let me have you answer a question. Melania.
10,900.
Which direction are we going? So we're going grams to kilograms. Where's grams? Where's grams? Right in the middle. Where are kilograms? How many over? Yes, so we're going left 3. So what do we get?
109.
0.109. To the left.
109,000.
Meters to kilometers. Somebody new. Meters to kilometers. Rosalind, which way am I going?
They're going left,
How many?
3.
Yep.
So it'd be 2, will it be 25,000?
You're going, so the decimal is right at the end, and we're going left 3.
Oh, 0.250.
Yep. So kilo to base unit, right 3. Base unit to kilo, left 3. Base unit to centi, right 2. Centi to base unit, left 2. Base unit to milli, right 3. Milli to base unit, left 3. All right, so which is greater? 56 centimeters or 6 meters? Allison?
6 meters?
Correct.
Jesus, is math.
7 grams or 698 milligrams? Michael? 7 grams. How many milligrams is 7 grams?
700.
700. 1,500 milligrams. 1.5 grams. Caitlin?
Equal to?
They're equal. 536 centimeters to 5.36 meters. Zach?
3.
Equal. All right. We'll do some more practice of that this week. So we can convert easily. Again, all those conversions you guys are basically doing in your head. If we're converting, feet to inches and inches to yards, you're not going to most likely be doing that in your head. So that's one of the benefits of the metric system. Once you're familiar with converting from one unit to another, it's relatively simple. So as you guys said, most of the world uses a metric system. You ever travel internationally, if you go to Canada or to Mexico, to Portugal, to any other part of the world almost, you're going to experience using the metric system. Now, do you guys have a good sense of metric units? If I say the temperature in this room is 40 degrees Celsius, is that close?
That'd be really should be like 23 degrees.
23 degrees Celsius?
No, it should be 30.
Well, 30.
So, do you guys have a real good sense of what metric units really mean? No, because if I said it's 103 degrees in here, you would know instantly, oh no, it's not. Because we understand our customary units much better, because most of us have grown up using those units, and so we're familiar with them. Since we have not, for the most part, grown up using the metric system, we don't quite have as good a grasp. But if you travel internationally, yeah, the temperature is going to be in degrees Celsius. You're going to buy gas by the liter. Okay? You're going to measure the weight of a piece of equipment in kilograms. Okay? So, depends on where you are. There are only really 3 countries whose standard system is not the metric system. They are Myanmar, which was formerly known as what? Anyone know a country? Lucas?
Oh, I know it.
Daniel?
Chile.
No. Silly? Are you just looking forward to dinner?
It's not.
All right, Grace? Burma,
Oh,
Burma, Liberia,
Yes,
and
it is.
guys, Western Africa, the United States, obviously. And what country is this?
That's the
USA.
All right, okay. All right. So every other country, other than those pictured in red, uses the metric system as their national standard. So, again, getting back to the benefits, when you look at the English imperial customary system, it just doesn't make any sense. Okay? As that to say, these whacked out conversions. And these are actual units that exist in the English system. So you have jacks, jills, jiggers, cups, pints, quarts, pottles, gallons, pecks, kennings, bushels, casks, barrels, hogsheads. That is an actual unit of measurement. Yeah.
Why isn't there a
And furlongs, leagues. Now most of these, where do these units originally come from? Like furlong or yard? Yeah, many of them come from agriculture, good, or commerce, and they're very old, hundreds and hundreds of years old. And, you know, like for example, a furlong is the distance a plow team could be driven without rest. So has an agricultural origin. A league is 3 miles, about an hour's walk. Okay, so they're not meant to really relate to each other like the metric system, where we have everything in powers of 10. So that's why some of these don't make a whole lot of sense. Mike?
Well, I went to one of the countries that like, even though they weren't one of those 3
Yep.
countries, they still used customary because they got so much tourism
Yeah.
from like the USA and like most from the USA that they
Yeah, well, a lot of places, like, sort of like, because if tourism is a big part of their economy, you know, people will speak English rather than their native language. People may accept currency, U.S. currency, or from other places.
They do. It just costs a little bit.
Some areas that have been part of colonization from England may still use English units in some cases. So
Yeah, that works.
there's a lot of different exceptions. But, so like, how old is the metric system? Ian?
Well, it depends, because there's been new things added, or like fixed.
How about, let's say, the origin of the metric system? Anyone want to take a guess as to when? Rosalind? 1400s? Anyone think earlier or later? What do you think, Lucas?
I think earlier. I think it's the 900s.
Okay. Sophia? Earlier too. Daniel?
Later.
Later, what do you think? Okay. Ian?
The Big Bang?
No.
Wow. The dawn of man.
All right, actually 1790s.
Dad was the only one.
In France, scientists started to develop a more standard and sort of more common sense international unit of measurement. And that's where the metric system came from. Now, it's all really so what's a meter? Where did they get the meter? Well, a meter was set at that. So if you're going to have a unit system of measurement, you have to say, okay, this is what a meter is going to be. How long is a meter? Why is it this long? Well, they used diameter of the Earth, and they made a meter 1/10,000,000th of the distance between the North Pole and the equator if you were to draw a line through Paris. That is where the original meter came from.
Wait,
And they have standard, if you go in Geneva, I believe, Switzerland, they have the standard. They have a bar of metal enclosed in glass that is meant to be the standard meter. And when we say we're talking about meters, this is how long it's supposed to be. And they have the same for mass as well.
have you been there?
No.
That would be cool.
All right, so that's a little bit about the metric system. What we need to finish up talking with is about measurement of length and area. Hello, Olivia. So, length and area. You guys would call this what? I never called it this, but you guys, what do you call that shape, that object? Rectangular prism. I would just call it rectangular solid. But so we can measure various dimensions of this rectangular prism. Okay? And we call those length, width, and height. We're not really that concerned about which one is which. In math, do you have to be specific? Like, what is length in math class? Like?
Well, the length is, it kind of depends on what you want to do, but since you're like dealing with some of the like types of operations that you could switch up, length is usually the the longer portion of it, it would
Okay.
be this part, like this.
Yeah, so we're gonna say, for our purposes, length is the longest side of an object. That's kind of arbitrary, but we're gonna say the longest side. Then we're gonna say width is the depth of the object, and then height is perpendicular to it. But really, they're not important to know really which is which, as long as you've measured all three dimensions. We're gonna have to measure areas of a circle. And so when we're measuring a circle, obviously it doesn't have sides, but it does have diameter and radius. So what's the definition of a diameter of a circle? Diameter. Awesome. What's that? Close, we just have to add a couple words. The length across the circle, 3 words. Is that?
In the middle.
Through the middle, through the midpoint. Yeah, has to go through the middle. So this would not be the diameter of the circle. What would that be called? Anyone know?
Wait,
No.
what was it?
Wait,
Wait.
From one side of the circle, not through the middle.
um,
I'm not even sure if I know.
I
It's
know
a
around
chord.
the circle.
Chord.
the line that's like on the bottom?
No, just from like here to here. I think would be a chord. We'll get to that in a minute. So what's radius then? So diameter goes from one side of the circle to the other through the midpoint. Radius, Madison?
I'm not exactly sure, but is it like, okay, I have 2 guesses.
All right.
It's either, probably not, but from the midpoint to the outside.
Yes.
Oh, nice, all right.
Or we can also call it,
The diameter divided by 2.
yes, half the diameter. It's half the diameter, or it's the distance from the midpoint to one edge of the circle, or the same.
Oh,
We also have some formulas that you're going to have to know about. We'll get to those in a minute. So the units for length that we will be using, millimeter, centimeter, meter, and kilometer. Those are the ones you should be familiar with. And just let's talk about them a little so we can understand what they actually mean. So we abbreviate all of them with simple lowercase letter abbreviations, millimeters being mm. How big is a millimeter? About how big, Sophia?
Like the size of this, well, no, I don't know.
Yeah.
I can't, like, small.
Small, but like the width of a human hair small?
No.
Daniel?
Like the width of your
Yeah, like the tip of your pencil maybe, pencil point, would be about a millimeter or so. It's about a 1/16 of an inch, those small markings on a English ruler. All right, centimeter, cm. How big is a centimeter? Lucas?
a centimeter is the abbreviation or like how big?
No, how big is it?
It's like, about like from the end of, like, it's like from where your pencil starts to turn into.
Okay, maybe. I would say the width of your pencil is close.
That's what I was.
About half an inch.
Isn't it
Yeah, maybe.
Wait, isn't it like 2.5?
Yeah, it's something weird.
What's
like
that?
It's
2.5, right?
Centimeters per inch.
Yeah, it's 2.5.
Around there. A meter, abbreviated with a single M. How big's a meter? Raise your hand. A meter. What's some new participants in this? Caroline?
Isn't it about 3 feet?
Yes, close to 3 feet. So what is it? What kind of stick is this?
Meter stick.
Is it because I paused? You switched your answer.
No, it's a yardstick.
What is it?
It's a yardstick.
Well, it depends.
It is a meter stick.
What's a meter?
A meter stick is a stick that's a meter long, Lucas.
Yeah.
What is it?
So
What is it?
this is 1 meter. It's close to a yard. So a yard goes to
It's like about
Here.
short.
so where my finger is, that's a yard. The whole thing is a meter. So it's about 3 inches longer than a yard. Okay.
That's why they.
About 3 feet.
Wait, in England they use yards.
Yeah. Well, they use a metric system now, but it originates in England. Kilometers? How long is a kilometer? Mahmood?
About maybe like the width of 4 buildings.
Okay. Maybe, I guess it depends on the size of the building. How about in relate, what do we usually use for longer distances? How does it relate to a mile, Caitlin? Daniel? No? Brad?
There's 2.2 in a mile.
Okay.
Is that?
Yeah, so it's about 0.6 miles. A kilometer. So if you probably are familiar with the Boilermaker road race. It's 15 kilometers. How many miles?
It's like 9.8.
9.3 miles. Yeah. So a kilometer is smaller because obviously if you're running the same distance, 15 kilometers versus 9.3 miles.
But it's usually more because you're using.
Yeah, Rosalind?
Wasn't it also like 5
Maybe, something like that. All right. So as we are measuring objects, as you are measuring objects tomorrow, typically what we do is we use millimeter as our unit until something is greater than a centimeter. Then we start using centimeters. And we'll continue using centimeters until it's a full meter. Then we'll use meters. And we'll continue to use meters until it's a kilometer, and then we will use kilometers. So we try to use the appropriate, obviously you could convert from one to the other, but we generally are going to use the proper unit that matches. Now, hold on. This an important fact when you're measuring things this week, often the end of a ruler is not the 0 mark. For example, on this ruler, the end is not 0. So you couldn't line this object up with the end of your ruler and measure it. You would be inaccurate. You have to start it at the 0 point. Now, why do they make rulers like this? Especially with wooden rulers, they do this. There's a reason. Why would they make this? Sasha?
Right? Guess maybe if you have to like place it on top of something, you kind of
Not a bad guess, but that's not the reason. Caroline?
you can whack it with something for the ends of break out.
Yeah, if I whack somebody with this many, many times, I might wear the end of the ruler away, and then it wouldn't be accurate anymore.
Wait, is that actually why?
Yeah. And so if you damage this part of the ruler, you could still use it and be accurate because you're not going to be using the edge. Your edge can be worn away. So we put our object at 0, we count the whole centimeters, and then we see how many millimeters it is. So this would be 2.9 centimeters. I need to finish up with this section though. So there's some formulas. I'll answer questions in a minute. Some formulas you need to know, and hopefully you already know them. What is the formula to calculate the area of a rectangle? Allison? Length times width. That's fine. Area of a circle. This is what people confuse sometimes. Area of a circle.
That is,
Raise your hand, raise your hand. Madison?
Isn't it like the diameter times something else?
No.
Dang.
Mike?
It's the diameter of the circle divided by pi.
No.
Damn.
Sophia?
It makes
I thought it
sense
was like
though.
the same like apple pie. Like
Apple pie.
it means like area equals pi times like. Oh, you know what I mean?
I know the formula, but just because I know it, I have no idea what you're talking about. Allison?
Because I remember the volume.
No. What's that?
Diameter times pi.
No. Lucas?
Area equals the radius squared times pi.
Correct. Pi r
It's
squared.
the same thing.
No, it's not.
The- well, the
What
radius.
is that?
Is the radius squared equal to diameter, Zach?
What is no?
Does squared means times 2?
Yeah, no, it means times itself.
No, it means times
Wait,
itself.
so what this is pi?
Area equals pi, 3.1415, times the radius squared. Squared means times itself.
Unless the radius is 2, then it's
Yeah.
this sounds like
Circumference is the length around a circle. What is the formula for circumference? Daniel. Heidi. Yes.
pi times the diameter.
Pi times the diameter.
Don't we still need a pi?
All right, we'll talk about solving problems involving area tomorrow, and that's what your lab involves. So we'll finish up with this tomorrow. Question, yes? No, why would they? They're never going to use it, and it's a